My name is Chang. I was born in Taiwan. I went to Canada when I was 14. So I have both nationalities of Taiwan and Canada. I completed my PhD degree in material science engineering at Tokyo Institute of Technology. Since then, I have stayed in Tokyo Tech as an assistant professor until now. The research work I have been doing is integration of various functional materials. In particular, is a specific functional material with flexible polymers. In this way, I can realize flexible functional materials with, for a lot of applications. So one study I have been doing recently is integration of a disinfectant material with our daily life clothes fibers. So in this way, I could realize disinfectant clothes fiber that could be used in our daily life clothes or to the mask we wear every day. Clothes fiber could help us to fight against very harmful diseases like COVID-19. And to realize this disinfectant clothes fiber, there are two challenges we have to solve. The first challenge is a material capable to cause inactivation of bacteria and virus under sunlight radiation. A visible light-driven photocatalyst can do this work. I have worked with Professor Yongzhong Xu from National Jiao Tong University in Taiwan from 2012 to develop this visible light-driven photocatalyst. So we realized this material by integration of metal particles with very high catalytic activity with semiconductor materials having various morphology and composition. The next challenge is integration of this photocatalyst with the flexible polymer. Because photocatalysts are usually ceramic material. They have very different physical property with those of polymers. For example, the Young's modulus, the expansion coefficient are very different. So when we do the integration, cracking and peeling between the two materials is often the problem. In order to solve this problem, there's something we can learn from the nature. We know that we can see that there are big trees standing tightly on the ground, and this is because they have roots extending deep into the soil. So this inspired me to develop a process mimicking root systems of plants. If we can use solvent to transfer materials into the polymer fiber, we could form root structures inside the polymer. In this case, I will use supercritical carbon dioxide as the solvent. And water is usually the solvent we use in chemical reactions, but it doesn't work here because water is a polar solvent. And polymers, they are usually non-polar. Supercritical carbon dioxide is also non-polar, and it has zero surface tension. These are all advantages in helping transfer of materials into the polymer fibers. So I have used this process to integrate visible light-driven photocatalysts with the clothes we wear every day, clothes fibers, to realize that disinfectant materials fiber that could help to fight COVID-19. The disinfectant clothes fiber not only block the harmful substance from entering our body, it also eliminates them when they come near us. The disinfectant clothes fiber will be the ultimate protection we could have to fight against COVID-19.